my composer.
Yeah.
And it worked. It's some kind of lengthy and memory. I need more memory. Yeah.
Can you show a little something? Or
yeah.
Yeah, would be great.
Can you, since I was not there last Friday, can you please share the link real quick? Actually, I was attending Rock am Ring with my son on Friday,
nice.
so that was important.
So we came to the point that we maybe for Mike as well, right? So Mike, you've got a question?
My friend is also called Ben, and he also sent the mail.
Let me check.
Sorry, I don't want to interrupt you, but
no problem. That's good that you say it. Yeah. Ben, you're right. Oh yeah, I see. I'm adding him right now.
Thank you so much.
Sure. So let me check. Here we go. Series and edit him as well. Now I should get an invitation. So yeah, basically we I have to share my screen right as well. We explore. So we are
okay.
Do you see it? Yeah. So normally we have basically for your other guys as well. We go through some OpenUSD educational content, but we also like cover other things which comes up. And currently we looked into Gaussian splatting and how to integrate it into Omniverse and Isaac Sim. And I came upon this these guys, Splatica. They've got like a really easy to use interface for converting 360 degree video to Gaussian splats, and you can download the Gaussian splats as well. And this is what we did last time. And we integrated in it. So here you have the Gaussian splatting scene, right, in Splatica. Maybe to give you an idea, you can basically look around and that's kind of a nice environment view for your digital twin environments as well, from my point of view. But still, you have to. If you want to integrate a physics simulation, we have to create like a collision mesh or something, as far as I've understood so far. I'm not sure what your experience is. Here is Ben as well. Ben, welcome. Can you maybe also give a little introduction, if you like, about yourself? You're muted. Yeah. Maybe if you don't want to, it's okay as well. Yeah, this is basically the scene, and we last time we used the kit extension for Gaussian splatting to read that into Isaac Sim. And it worked basically. I've also published the video excerpt from last time. And Andy, you're dealing with anti-gravity drones, right? And
mainly with the DJI avatar. This is the affordable drone.
Yeah.
And but I did see since our last session, Splatica integrated also A1 drone scenes.
Yes, they're really like not too so really let's say innovative, I'd say.
Yeah, and they work together with anti-gravity.
Yes. And also Insta360. So I guess.
Yeah, also Insta360.
Yeah.
Also, I did mention when you fly with a drone, you with a 360 degree cam, you fly in a different way. With a normal camera system, you fly as close as you can to the point of topic. This is not affordable with a so you fly in a straight line with a 360 camera and mainly smooth flight. This is important. And so you fly in a different way for the 360 cameras. And on Splatica is also a fly guide. It's interesting.
Okay.
I did mention this in the session before the last session.
Okay.
And since then they wrote a guide for a fly guide also. It's
nice.
quite interesting if you want to do this.
With the drones, yeah. Did anybody else capture drone footage for digital twins?
No.
That's should be also interesting, yeah.
It's quite new.
Yes. Yeah. That's leading edge, basically, right?
Since 2 months, there are 360 degree cameras in the consumer field.
Yeah. If you like to share some screen, share if you
I have some Splatica scenes.
Yeah. In Omniverse, that would be great.
Yeah.
I don't see it yet.
Do you see this? This is a place in Turkey. It's, maybe you noticed this is buildings built in the rock. It's a quite famous tourist.
And you took this by yourself, no?
No. It's from Splatica. They released a lot of PLOI scenes in the last week.
Nice.
This, you can just take this. Dalian, Turkey is the name of the scene.
Okay, great.
Also, I have from I1 the anti-gravity scene.
Yeah, that's good. So.
And there you see the anti-gravity drone.
Yeah.
This is a drone with a 360 camera system.
And do you also have already a method to convert the Gaussian splat to a 3D mesh?
No, not my recordings.
Yes,
because I don't have a workflow like this is possible with this drone.
Okay.
I dropped some links here, so there should be a link in here where you have NVIDIA GitHub repo where this is possible, where you either convert it to Gaussian splats, so any footage that you have, or that you generate a 3D scene out of it. So this is totally doable, and just have to figure it out.
Well, I haven't figured it out yet. So here is
it works quite good. It's takes some time and some memory. This is chapel in France, I think.
Nice.
Yes, awesome. You see the visitors.
Awesome. Cool. So thanks for sharing. Maybe so I think till next time, somebody can like find out how to convert the splat into.
I have to.
Yeah, that's good. Because in this talk, they also show it. I share my screen real quick.
It's my next step because I have done the recordings and now I need the PWI file.
Yes. So here they basically tell, they create like a mesh from the so they have the splat, the Gaussian splat, and the mesh, and then they integrate this both. They use the mesh as a physics collider, right?
Yeah.
Because that was the last time the question: how would I like add physics simulation to this, right? And so for the physics simulation, you use like this collision mesh, and for the visual representation, you use the Gaussian splat. Yeah. Right. Nelson, yeah, good. What? Yeah, thank you for all your links and information. I think that's good. We can work from that. Nelson, do you like? Did you have experience with that already? What's the like performance and does it work well?
You're muted.
You're muted. Yeah. Yeah.
Nelson.
I think he can just write. Yeah, still trying. Good. Yeah. Maybe should we go to the USD in a weekend next chapter? Maybe if you have anything else for the Gaussian splatting, I'd leave it to next time. And MC, I don't know. Have you been here before?
I just invited, sorry, because he's also interested. His name is Miguel, and Miguel, you can introduce yourself. Sorry about that.
Please. Yeah.
Hi everyone. Yes, I joined later, thanks to Jesus. But I'm Miguel from DataDo, where we are working with synthetic data, and we are very interested in this technology and everything we can leverage from this splatting.
Yes, awesome. So welcome.
Thank you very much.
So we currently for you new guys, we have completed the OpenUSD learning path before, and right now we're going through the OpenUSD in a weekend, which is a free online book, and we just like go through the examples and do them together and like answer questions. There is some starting material, so you can go through this and do some initial installation. But if you have already USD environments, like Omniverse or Blender or USD View, you can also work with it, right? Yeah. So I'd say last time we managed to build this USD scene, right? With the cubes, and we transformed them, and we also checked out what the sequence of transformations has an effect. And I think now we're moving to making OpenUSD animation, right? So I think these are like basic things to look into when doing animation, composing clips. And I just read it briefly, and you can read it by yourself as well, and we just go like along, right? So first we need to introduce the fourth dimension of time by applying timeline to our stage. Timeline, exactly. Also, if you have here the USD composer, you can do like animation timeline, right? And you get like the timeline here. Animation, by chance, I have an animated warehouse scene here, for example, right? And if we start the animation, right, you see it's moving. So yeah, this is just a simple time frame animation. Like you have for each sample, like each point in time is a new position. And as we have seen before, each attribute in OpenUSD can have a lot of different values on a timeline, right? So not only one, but yeah. And as you add more time sampled values, you get an animation. Right? So once we have our timeline in place, we can start defining the movement and transformation of objects, lights and cameras. You can basically animate anything. Specific movement time, we create keyframes. Yeah, keyframes, that's the word. Control timing and extent of animation. We'll also explore to smooth out animations. Yeah, interpolation is a good thing. And we bring everything together in an example again. Yeah, makes sense. So setting up stage properties, yeah, that's a good thing. The stage properties serve as a backbone, allowing you to control the global animation parameters. What purpose? Yeah, there is a question.
No, Ed Nelson. That was Ed Nelson.
Oh yeah. Okay. Creating animation. Yeah. Yes, we have to like the frames per second. Yeah, that's a parameter we set on the stage. Frames you integrate this for 3 seconds. Most movies run at 24 FPS, so we want to have 3 seconds, and so we need like 72 frames. Yeah, makes sense. Yeah, following USD zero-based indexing, where counting begins at 0 rather than 1. That could also be a question in the certification. How do you say, like certification exam? Yeah. To determine the right time in a time frame. All events can be thought of happening on a timeline. The point at which they occur in the timeline is given as a time code. Yeah. Timeline serves as a tool that organizes when and how different elements in a scene move or change over time, allowing animators to control the pacing and synchronization of events within the animation. Yeah, let's see how we do that. Understanding time code, yeah. That comes from the film, yeah, SMPTE. Maybe you have heard that. Synchronizing assets, strict, yeah, all highly flexible. Yeah. So every scene can basically have different frames per second, for example, and it aligns then if you combine it. Yeah. Frames per second. Yeah. Smoothness. Yeah, can be thought as playback resolution. Yeah, that's good. And you can like get this by get frames per second method. Yeah, makes sense. Time codes per second value indicates the number of samples of time that are taken per second of animation. Does not determine the output rate, only the calculation rate. Set time codes per second. Okay. You're working on a pre-existing stage and need to know the time codes per second. You can use this method, yeah. Time codes per second can be thought as a temporal resolution. Increasing, yeah, blah blah. That's useful. I skip over that, right? You can read it yourself. Yeah. Yeah. So yeah, basically, yeah, the time codes per second is like the resolution, and it plays with 30 frames per second. Yeah, makes sense. Interoperability. And so we go to the timecode class. That's basically our representation of timecode in USD. I think I'll go over that as well, right? So we just deal with time codes, but not with like milliseconds or something, you know? So it's just a time code. Yeah. Specifying what time actually, yeah, like seconds or frames. That's what I just said. It's a placeholder for marker in time in USD files. Yeah. And by looking at the frames per second or time codes per second, you like get then the actual can calculate then the milliseconds, for example. Yeah. Start time, end time, time codes per second, fundamental parameters. Yeah. Control the timing. And here we have like our example timeline. Yeah, we have 2, 4, 6, baby. How many frames per second are there? A lot. Start time, end time, and like our seconds. Yeah. Okay. Yeah, now we get to code. Let's create a new stage and set it up. Remember to ensure what you're operating with this. Working for chapter 7. Use the USDA format. By chance, do you know in Composer where to set the time as well? Basically, in the timeline, you can set it here as like frames per second, right? And here is like the end and start time. And if I set it to 1200, it's basically setting here. Okay, it sets the end and start time code like this. So that's basically doing it programmatically what I just put into my UI, right? High FPS, smooth or fluid. Yeah, if you have a lot of time codes, it goes into performance, right? So access in the timeline, I just told it. That's also accessible in every tool. I just showed the timeline in Composer. You have the same in USD View or in Blender as well. Yeah, is anybody using Blender? Yeah, Jan, can you show it or where the time code is in Blender?
I didn't really pay attention right now. Basically, the timeline.
Yeah.
Actually, I can't right now. So do you want me to open Blender or?
Yeah, if you have it, but
give me a second.
Yeah. Just if you see you guys, that we can where it is.
You continue while I open.
So creating animations, blah, 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 understand keyframes. Well, yeah, this basically describes the concept of keyframes. That's basically, yeah, animation basics. So how should we go into that in the or should we go to programming more?
Is the animation graph a topic of the certification?
No, that's actually here time sample animation. That's good to differentiate because in Omniverse there is animation graph, which is basically a different concept.
Yeah. Okay. Yeah.
But yeah, animation graph is not part of the standard OpenUSD yet. So here they concentrate on time keyframe animation.
Okay.
So Michael, one question here.
Yes.
So basically with the animation, what we can do is taking a USD from the Isaac library, let's say a universal robot arm cobot or something else from the library, and animate it in a new stage in Isaac.
Yes, for example, yeah.
Okay, as long as we have the rig in the asset.
That's also a different kind of or an additional kind of animation. If you have like a skeleton or a rig, as you say in the model, you can basically then either define the position for each how do you say, like bone or skeleton piece.
Okay, yeah.
Right. We can put that. I'm not sure if or you can let it drive by the physics engine. So this is not keyframe animation then. So if the physics engine like moves stuff, it just moves according to the specification of the physics, right?
Okay.
But you have the possibility to record this movement and replay it as a time sampled keyframe animation as well. So
okay, so let's say that I have some waypoints in the space, and I want to move the end effector of the cobot to those points. So I can move it with the physics, and then record that animation, but it's different from what you are showing now.
Yes, that's also probably an inverse kinematics solution before. So because you say you move the end effector, and the other parts of the robot like they move accordingly, right? So,
exactly, that's what I would like. The inverse kinematic of that.
That's totally possible, but that's inverse kinematics. You can also do this programmatically, and then record it and replay it basically as an animation as well, if you want to do that.
Okay, and to record that is how would I do that? I have no idea how to record that as to replay that afterwards.
There are several possibilities. There is a scene recorder, for example, if you want to do it in with the UI, or you can also do it programmatically. Just move it like I mean, Julian maybe already did that. Could that be?
Exactly. Yeah.
Yes.
So we're doing a few different projects in this regard with different kinds of virtual commissioning of machines. So there's a few projects where we do proper kinematization with the physics and with articulation trees and joints. And for just showing how a machine should behave in the ideal case, you usually use the animation. And also for the conveyors, it's way easier to handle. I'd like to stay, but I just get another call and gotta leave again. Sorry.
But
But have a nice remainder of the study group.
Right piece of information.
Thank you, Julian.
Awesome. Yeah, Julian is doing a lot of virtual commissioning and stuff. So Jan, you had the Blender thing going?
Yeah, I can quickly share my screen.
Yes, please.
Here we go. Yeah. So so this is Blender. Who's familiar with Blender? Nobody? Okay. In order, Blender has a wicked interface. Like if I go here and make a right click, I should be able to wait. No, it doesn't work. Anyway, so in order to get to this window, I have to split, like split. Where can I split it? Anyway, no, there's a way to get to this window, and then in any window you can open like up these here. So I'm in the video sequencer. I could also switch this to the node editor for textures, but I'm in the video sequencer. And here in the video sequencer, I just set a certain keyframe at a certain point. It should be able to see it. I haven't worked with this in a while, actually. I used to work with totally different software. So basically you set a keyframe, and then you go to different position and time. Like in here, I set another keyframe and then I keyframed it. Now it's, oh wait, no, doesn't make sense. Now I just go a little further here, right click, insert keyframe, and then you have to export it as USD with the animation activated, and then you will get this sort of path. You can see that it's interpolating, so there's a lot of things that you can do, which I haven't worked too much with this one here yet. Anyway, and then when you import it into Omniverse, Michi, are you familiar with Omniverse, whether it now can do interpolated curves, animation tracks and stuff?
Yeah, it converts it to animation graph.
So this is its own thing. We could go into this as well. Basically, here you have a curve which is interpolated. So you can, and by the time you import it into USD, USD can't interpret these interpolated curves yet. So you get, for every keyframe, you get like a new point. So you have some sort of a baked animation, they call it.
Yeah, that's maybe something for the next steps with the animation paths. But thank you. Here we see like the keyframes and how like it goes through the timeline and moves, and that's basically what we see here in the graphics, right? So Jan has moved his cube and advanced the timeline, moved it again, advanced the timeline, moved it again, and in the time between, it's interpolated, right? Yeah. So keyframing and translation. Okay, so here now things get a little more interesting. So what happens here? We create a cube. We create a translation operation.
Share the screen again? Oh, sorry.
Thank you. Yeah, Oh man, yeah. So I talked about this, right? The keyframes, and now we got into like the keyframing translation, and I just was referring to this code. So what happens here? We define a cube, we add a translation operation, and we set here, you see, normally last time we just set the translation without a time code. So that's basically setting a static translation. And with this USD time code, we set it the position in time, right? So here we set it to 0, 0, 0, and here at time code 30, we set it to 10, 0, 0. Yeah, let's try this and see where we come out, right? I think and so here we also set the scene, right? I think this time I'm gonna go again with the script editor. Any preferences? Here. Let's see, frames per second, right? That's the stage setup. Say, let's do it like that. And what's inside here? If we just open that, where has it been? Oh, come on, open it. Animation _ 1 USDA. Oh, it's in Kit app template. Okay. Yep. So I've opened animation 1. Yeah, nothing to see, right? It's empty. But here we see our timeline, right? And time goes from 0 to 59, as we said, right? And frames per second is 30. So yeah, so to mention here, we have so this is our time codes and not seconds or something, right? So, but I think we can switch to seconds, right? What do we expect when we switch to seconds? 2 seconds, basically, right?
Conversion of the frames, right?
Come again?
So what do we expect when we convert to seconds, you said?
Yes.
Yeah, to multiply by the FPS, right?
Right. To divide, basically, yeah. So here you see now I've switched from frames to seconds, and here I see now the like the from 0 to actually yeah, the 2 minus like this one frame. Makes sense. So let's then add our cube and try to animate it as we see here. Zoop. Let's take it from 2, right? So what we add a cube, we add a translation op, we and set our time codes, right? And so and we save it. Let's do that. I'll open it. Let's go to this directory real quick. Kit template, and it should be here, right? Yes, animation 2. Isn't it? So, makes sense. We have our cube. And if we select the cube, nothing fancy. It's at position 0, 0, 0. But as we now move our time, see, it moves. How long does it move? Just 1 second, right? Because why is that? We set time code 30, right? And then it just stays. Yeah, that's what we did. Key from value time code object. Yeah, it explains basically that it's just good to have time codes instead of like a second related time or something. No. Interoperability, yeah, a lot of APIs expect USD timecode objects. Makes sense. Yeah, that's also a good question. Why isn't that an integer, the time code, right? You don't say at time 1.7. You say it at time frame, 30, for example, right? That's more interoperable, because you don't have this floating stuff, right? Keyframing, yeah, same goes for rotation. Let's do that. Let's just add the rotation here. What happens? We also add the rotation X, Y, Z to our cube, and we set say an initial rotation of 0, and then we rotate around the C axis 90 degrees, also with the time code 30. Let's maybe change that to 45 to see what happens. Huh?
Maybe it could be hard to see because it's a cube, and when you rotate it in 90 degrees, you cannot see the actual turning. All the sides are same, I won't say.
Yes. But basically, through the interpolation, we see some movement. I think that's
yes.
That's the benefit here. Let's go to 3, enter it. It did work out. Same. So what do we expect? We should, like in the first half of the animation, our cube should move and rotate, and a little more through the animation, it should stop moving, translation, but also still rotate a little. Let's see. Yes. Oh, that's good. See, it starts to rotate. And here at the half of it, at 1 second, it stops translating, and then it moves to the 90 degrees around like this later time code as specified. Makes sense? That's about quaternions. Yeah, basically there are a lot of different ways to specify like rotations and depending on your use case. Yeah. Transformation order, right? What does it do? Yeah, here it like also rotates stuff. And also we can scale that as well. Let's add some scaling. Makes sense. So here scaling, sure, in identity scale is 1, 1, 1, right? To make it even more interesting, let's scale it back to. So we scale it from 1 to the 5 factor, right? And then let's scale it back to 1, 1, 1. I'd say at our 15, right? That's the end of our animation. Export, right? So let's see what happens. We scale, and translate and rotate, right? And then we scale back, and we're done. And by this, we can like assemble any movement we'd like to, right?
Michi?
Yes.
In the chat, I dropped in the USDA from my animated cube.
Ah, yes. So let's see what happens here.
I hope it exported the animation. Let me check.
Let's see what it did. Do we see any? No, we don't see anything. So here, yeah, that's the good thing. Let's keep that and export or look into our USDA what we just created. So how does it? So here's you see the file of Jan, right? You see a lot of points. That's basically the cube. And if we then open our USDA, we can also, if you know that, you can also right-click here on Edit, and then you get the ASCII representation, right? So if you now let's compare those two guys things. Maybe
not sure if I exported the.
No, you haven't, because
no, there's no animation exporter, right?
Yes, because if we look into our into this file, you see we have a world, we have a cube, and here we have time samples, right? For rotate X, Y, Z, it's at this time frame, this value, at this time frame, this value. You said we saw we did for the scaling, we specified 3 values at 0, 30, and 59. These are those, right? And for the translation here as well. And if you compare this with what you sent, Jan, we have only the one value for this operation, right? So yeah, that's a.
Wait, I'll try one more thing, because I exported this with my plugin, and obviously I haven't included animations in there.
Yeah, try to export with animation. Yeah, it should then look like something like this.
I have also a good example to
and
we can show, and you can see. Maybe I'll start to sharing my screen.
Yes, please.
This is what I made before in Blender. very quickly small animation. This is like a simulation for a cylinder, and if I go to play animation, it looks like this.
Yeah, awesome.
And I also applied for the rigid bodies for the cylinder, actually only the cylinder form, and also for the cube, for the Würfel. And I exported this simulation, or not simulation, like this animation Blender project into a USD file. It looks like this. Here I open it in the USD view, and under the USD view you can also see the timeline. You can also play it and show it how does it works. And here are some attributes. Those attributes are green because it's time sampled. It's it's time varying in different frames. You can see if I choose different frames, you can see the translated the translate is different in different values. So this is kind of animation play in USD file. But sorry, I make it in the USDC, so I cannot show the USDA the text in the editor. I need to convert it to USDA. But this is also a very good example.
That's awesome. Yeah, thanks a lot for showing. Yeah, and
I pasted the one with the animation now.
Yeah. So we have lots of different. Yeah, see that's how it looks like. Yeah. Maybe share my screen again. There we go. So before it was like this, right? So scale, and now we have the time samples instead.
So I started with frame 60, pretty much. So 134. So it's basically in order to get the animation across, it's baking the animations into every frame.
Yes.
Yeah. With the transforms.
Yeah. Great. So yeah, I think we got a good impression of like keyframe animations. Time is already over again. So thanks for all the contributions. I think it was really a good different angles on it with the different tools. So if you guys want to share something next time, or feel free. Also, if you want to try the Gaussian splatting with the collision mesh and want to share it and try how that works, that would be great.
Yeah.
And,
thank you very much.
Yeah, for now, have a good day and weekend, and see you next time.
Oh.
Bye.
Thank you, Michael.
Thank you.
Bye.
Bye.
Thank you. Bye.